When you look at our planet, what do you see? A world of just staggering beauty, right? You've got towering mountains, vast deserts, and a world that cycles through these predictable seasons, just teeming with an incredible diversity of life. It feels permanent, stable. But what if I told you this piece is a very, very recent development?
Was our home always this peaceful blue and green marble floating in space? The answer to that is a hard no. The true story of our planet isn't one of peace at all. It's a 4.5 billion year epic of violence, chaos, and a transformation that's almost impossible to imagine.
Just look at the difference. On one hand, you have the early Earth, a molten ball of fire, constantly getting slammed by meteors, choked by a toxic atmosphere, and completely, utterly lifeless. And on the other, our home today. So how on earth did we get from that hellscape to this paradise? Well, to find out, we have to go back all the way to the beginning. Now, our story doesn't actually begin with Earth. It begins before Earth, before time, before space, before anything we could possibly recognize. I want you to imagine everything that exists. Every single star, every galaxy, all of it compressed into a single, impossibly dense point, smaller than an atom.
Then, in an instant, bam, the Big Bang. The entire universe just explodes into being. At first, it's this chaotic soup of energy and hydrogen. But pretty soon, a new fundamental force shows up, gravity. And it patiently begins its work, pulling little particles of hydrogen together, compressing them tighter and tighter until, whoosh, they ignite in nuclear fusion. The very first stars are born, lighting up the cosmos. And in one corner of this brand new universe, inside a galaxy we'd one day call the Milky Way, a giant cloud of dust and gas collapses in on itself, giving birth to our very own star, the Sun.
Circling this brand new star was all the leftovers from its birth, basically clouds of dust and rock. And gravity, well, it went to work again, pulling all this debris into clumps. One of these clumps was destined to become our planet. But this early Earth, it was nothing like the world we know. It was a superheated, molten ball of liquid rock. This early period, known as the Hadean Eon, was just pure chaos. Meteors rained down relentlessly, and every single impact just added more and more heat to this molten surface. This wasn't a world of solid rock. It was a world of flowing rivers of lava. Millions of volcanoes were erupting constantly, spewing toxic gases into an atmosphere that had absolutely zero oxygen. Seriously, if you looked at this primordial hellscape, you would never ever guess it would one day host life. And just when you thought things couldn't possibly get any more violent, Earth's single most catastrophic event was about to unfold. An object was on a collision course, and let me tell you, this was not just another meteor.
It was a protoplanet named Theia, and it was roughly the size of Mars, hurtling directly towards our young Earth. The impact was inevitable, and it was going to be unimaginably powerful.
The collision was just beyond belief. It blasted a huge chunk of both planets into space, which formed this glowing ring of debris all around Earth. Then, over thousands of years, gravity did its thing and pulled all that rubble together, creating our moon. But that's not all it did. The sheer force of the impact physically knocked Earth over, tilting it on its axis by 23.5 degrees. In a single moment of absolute cosmic violence, our seasons were created, and our climate was stabilized, a totally crucial step for the future of life.
Okay, so after the moon was formed, Earth began this long, slow process of cooling down. And this is where the story shifts from cosmic destruction to the really delicate creation of life. And the very first ingredient we needed was water.
So this key ingredient for life came from two places: icy meteorites that kept bombarding the planet and water vapor released by all those volcanoes. This kicked off a global rainstorm that lasted for millennia, finally cooling the crust and forming the first oceans. And deep in these oceans, near these superheated volcanic vents, a miracle happened. Chemicals combined to form the first amino acids, the actual building blocks of life. But the journey was nowhere near over. The planet then plunged into a deep freeze, becoming a snowball Earth. Life barely hung on until massive volcanic eruptions pumped the atmosphere full of CO2, creating this huge greenhouse effect that melted the ice and finally paved the way for complex, multicellular life to flourish.
But where did that first spark of life really come from? Well, science has two leading theories. The first one suggests it was a homegrown chemical reaction. Lightning and volcanic activity provided the energy to forge amino acids right here in Earth's early oceans. But the second theory, panspermia, is even more radical. It proposes that life didn't start here at all. The idea is that Mars, since it's smaller, cooled down faster, allowing simple cells to develop there first. Then, a massive asteroid impact could have blasted Martian rocks containing these tiny microbes into space, which eventually crash-landed right here, seeding our young planet with life from another world. How cool is that?
So regardless of how it began, life absolutely exploded. Over hundreds of millions of years, evolution produced this incredible array of creatures. But one group would come to dominate the planet like no other, kicking off a whole new era, the age of the dinosaurs.
For more than 150 million years, they were the undisputed kings. I mean, from massive herbivores on land to terrifying predators in the sea and winged pterosaurs in the sky, every single major ecological niche was filled by a dinosaur. It was their world. We were just a distant mammalian possibility.
Their reign felt eternal, completely unstoppable. But, the universe had other plans. Once again, the greatest threat to life on Earth would come from the sky.
I want you to try and picture this. An object larger than Mount Everest, screaming through space at over 22,000 miles per hour. That is so fast, it could cross the Atlantic in under 10 minutes. As it entered our atmosphere, it became a fireball, so bright and so hot that dinosaurs on the ground could feel its heat long before it ever struck.
The impact, in what is now the Gulf of Mexico, was cataclysmic. It triggered an earthquake estimated at a magnitude 12. That's stronger than anything humans have ever witnessed. It vaporized rock and sent it flying back into the atmosphere, which then rained back down as molten glass, starting a global firestorm. Mega tsunamis washed over the continents. And maybe worst of all, a thick cloud of dust and soot enveloped the entire planet, completely blocking out the sun for years. And the result was a mass extinction on a scale that is just hard to wrap your head around. Without sunlight, the plants died, the herbivores starved, and the carnivores soon followed. In the end, a staggering 75% of all species on Earth, including every single large dinosaur, were wiped out. Forever.
But in every great destruction, there's an opportunity. The only creatures that survived were the small ones, generally under about 25 kilograms. They could burrow, they could hide, and they could survive on less food. And hiding there in the shadows, a new class of animal was ready for its moment: the mammals.
With the giants gone, the world was basically an empty stage. And mammals, our distant ancestors, stepped out of the shadows and began an evolutionary journey that would, eventually, lead directly to us. So the path to us was long, and it was driven by constant change. Mammals absolutely flourished in the dinosaurs' absence, diversifying into thousands of new species. One branch took to the trees, evolving into primates. Millions of years later, climate change transformed Africa's lush forests into open savannas, which forced some apes out of the trees and onto 2 feet. This pressure to adapt caused this lineage to branch out, eventually leading to gorillas, chimpanzees, and a new line that would become Homo sapiens. When you really think about it, our presence here is nothing short of a miracle. We are the result of a story written by stardust, shaped by gravity, interrupted by planetary collisions, and made possible only by mass extinction. Every single step along the way was a roll of the cosmic dice, and against all odds, well, here we are.
And that, of course, brings us to the final crucial question. Our planet has survived molten lava, planetary impacts, and global ice ages. It is incredibly resilient. The question now is, after 4.5 billion years of survival, will the next great threat to life on Earth turn out to be us?